Building the transformer block. Welcome to the heart of our Shakespeare GPT. The transformer block is where the magic happens. It's like a super smart brain cell that can understand relationships between words. When we look at our visual flow diagram, we can see how the process moves through three main stages. First, we have the multi-head attention mechanism, which then feeds into the feed-forward network, and finally that leads to smart text understanding. This is like a smart assembly line where each step makes our AI understand language better. Now, let's look at the memory tip section. Think of a transformer block like a smart student who, 1. Pays attention to important words, 2. Thinks deeply about them, 3. Remembers the original idea. Just like how you focus on important parts when reading a story, our AI does the same thing but with superpowered attention. What's inside our transformer block? Let's explore the three amazing components in our comparison boxes. Multi-head attention, like having multiple pairs of eyes looking at different word relationships simultaneously. Feed-forward network, a thinking layer that processes the attention results and makes decisions. Layer normalization, keeps the learning stable, like a good teacher keeping students focused. Each component works together to understand text better than any single method alone. Now, let's check our easy remember section. AFN, attention, feed forward, normalize. Like reading a sentence, focus, think, remember. This simple pattern helps you remember how information flows through our transformer. It's just like how your brain works when reading. Let's build our transformer block. Looking at our first code section, class definition and setup. Class transformer block end module. Combines attention with networks. Def in itself, embed dim, number heads, ffdim, dropout equals 0.1. Super init, multi-head attention. Self-attention equals multi-head attention, embed dim, number heads. Here we're creating the blueprint for our transformer block, setting up all the tools we need. Now our second code section, feed forward and normalization. Feed forward network. Self.feed forward equals n and sequential. And linear embed dim, ffdim. And ReLU. And linear ffdim, embed dim. Layer normalization. Self.norm1 equals and layer norm embed dim. Self.norm2 equals and layer norm embed dim. Self.dropout equals and dropout. This builds our thinking network and stability systems, like installing both the engine and steering wheel. We're creating a smart block that can pay attention and think deeply about text. How data flows through our block. Looking at our forward pass code section, the magic happens here. Def forward self, X. Step 1. Attention with residual connection. Attention out equals self.attention X. X equals self. Norm 1X plus self. Dropout attention out at original plus new info. Step 2. Feed forward with residual connection. FF out equals self, feed forward X. X equals self norm 2X plus self dropout FF out at original plus processed info. Return X. This forward function is our recipe for understanding text. First we apply attention, then add those insights to our original input. Our visual flow shows how the process works step by step. We start with the input text, which goes through what we call attention magic. From there, it moves to an add and normalize step, then we have a think deeper phase, and finally we get our smart output. Now, let's look at the residual connection trick section. We always add the original input back. It's like keeping your original thought while adding new insights. This prevents our AI from forgetting important information as it learns new things. Building complete Shakespeare GPT. Now we combine everything into our Shakespeare story generator. This is where all our hard work pays off. Our visual flow shows the complete process from start to finish. We begin with word embeddings, then we add position info to give context about where each word sits. Next, the data passes through multiple transformer blocks where the real processing happens, and finally we reach the end goal, predict next word. Looking at our three comparison boxes. Embeddings, convert words to numbers the AI can understand. Positions, tell the AI where each word sits in the sentence. Prediction, generate the next word like Shakespeare would write. We're building an AI that understands both what words mean and how they work together to create beautiful stories, just like Shakespeare did. Shakespeare GPT class setup. Looking at our class definition and initialization code section. Class Shakespeare GPT and module. Complete GPT model. Our Shakespeare story generator. Def in itself, vocab size, embed dim, number heads, number layers, ff dim. Max seek len, embedding matrix equals none. Super init. Self.vocab size equals vocab size how many different words we know. Self. Embed dim equals embed dim size of word representations. Self. Max seek len equals max seek len maximum sentence length. We're creating the DNA for our AI, defining how smart it will be and how many words it can understand. Now, let's look at our tip section. What these parameters mean. Vocab size equals dictionary size, embed dim equals word richness, max seek len equals memory span for context. Each parameter carefully controls how our AI will think and create. We're building the foundation for digital creativity. Setting up word and position embeddings. Looking at our first code section, word embeddings for meaning. Word embeddings using our word to-vec. Self-token embedding equals n an embedding vocab size, embed dim. If embedding matrix is not none. Self.token embedding wait, data.copy torch, float tensor embedding matrix. This gives our AI a way to understand what each word means, like giving it a super smart dictionary. Our second code section, position embeddings for order. Position embeddings word order matters. Self.position embedding equals n. Embedding max seek len, embed dim. This tells AI, the at position 1 is different from the at position 5. Position matters. Dog bites man is very different from man bites dog. Our visual flow shows how we process the phrase, to be or not. First, we convert it into word vectors, and at the same time we add position vectors to track where each word appears. When we combine these two types of vectors together, we end up with a rich understanding of the text. We're combining meaning with placement to create true language comprehension. Stacking transformer blocks. Looking at our multiple transformer blocks and final output code section. Multiple transformer blocks, the brain layers. Self.transformer blocks equals n, module list. Transformer block embed dim, number heads, ff dim. 4_ in range number layers stack multiple blocks for deeper understanding. Final layer normalization, keep things stable. Self norm equals n, layer norm embed dim. Output layer predicts next word from vocabulary. Self output layer equals linear embed dim, vocab size. We're building layers of intelligence. Each transformer block adds another level of understanding. Now, let's check our tip section. Why multiple blocks? Like having multiple smart friends review your writing, each one catches different patterns and meanings. More layers mean deeper understanding, just like how you understand stories better when you read them multiple times. Complete forward pass. Looking at our How Shakespeare GPT processes text code section. Def forward self, x. Batch size, seek len equals x.shape. Create position indices 0, 1, 2, 3. Positions equals torch, arrange 0, seek len.unsqueeze 0. Repeat batch size 1. Get word meanings and position info. Token embeds equals self, token embedding x what words mean. POS embeds equals self.position embedding positions where words are. Combine meaning plus position equals rich understanding. X equals token embeds plus POS embeds. This code creates position numbers for each word, gets their meanings, and combines everything together. Our visual flow shows how we prepare text for processing. We start with raw text input, then we add word meanings to give each word its semantic value. After that, we add position info so the system knows where each word belongs in the sequence. Once we've completed these steps, everything is ready for processing. We're preparing our text so the AI can understand both what words mean and where they appear. Final processing and prediction. Looking at our through all transformer blocks to final prediction code section. Pass through all transformer blocks layer by layer learning. For transformer in self.transformer blocks. X equals transformer X. Each block makes understanding deeper. Final normalization polish the final result. X equals self norm X. Predict next words the magic moment. Logits equals self output layer X convert to vocabulary probabilities. Return logits. These are the word predictions Shakespeare style. Each transformer block deepens our understanding. Then we make final predictions about what word comes next. Our visual flow shows rich text understanding, arrow, multiple transformer blocks, arrow, final normalization, arrow, Shakespeare-style predictions. Now, let's look at the final magic section. Our model now thinks like Shakespeare. It predicts the next word based on deep understanding of language patterns. We've created an AI that can write poetry and stories just like the master himself. Complete production code. Looking at our complete transformer block class code section. Class transformer block NN module. Def init self. Embed dim. Number heads. FF dim. Dropout equals 0.1. Super init. Self attention equals multi-head attention embed dim. Number heads. Self.feed forward equals NN sequential. And linear embed dim. FF dim. And then real U. And linear FF dim. Embed dim. Self norm 1 equals N layer norm embed dim. Self norm 2 equals N layer norm embed dim. Self.dropout equals N dropout. Def forward self X. Attention out equals self attention X. X equals self norm 1X plus self dropout attention out. FF out equals self feed forward X. X equals self norm 2X plus self dropout FF out. Return X. This is our complete transformer block, the building block that makes everything possible. Each line works together to create intelligent text understanding. Complete Shakespeare GPT code. Looking at our complete Shakespeare GPT class, production ready code section. Class Shakespeare GPT and module. Def init self, vocab size, embed dim, number heads, number layers, FF dim, max seq len, embedding matrix equals none. Super init. Self vocab size, self embed dim, self max seq len equals vocab size, embed dim, max seq len. Self.token embedding equals n embedding vocab size, embed dim. If embedding matrix is not none. Self.token embedding wait. Data.copy torched float tensor embedding matrix. Self.position embedding equals n embedding max seq len, embed dim. Self.transformer blocks equals nn. Modulist transformer block embed dim, number heads, FF dim for underscore in range number layers. Self.norm equals end, layer norm embed dim. Self.output layer equals and linear embed dim, vocab size. Def forward self, X. Batch size, seq len equals X shape. Positions equals torch, arrange 0, seq len dot unsqueeze 0, repeat batch size 1. Token embeds equals self, a token embedding X. POS embeds equals self, position embedding positions. X equals token embeds plus POS embeds. For transformer in self.transformer blocks. X equals transformer X. X equals self norm X. Logits equals self.output layer X. Return logits. This is our complete Shakespeare GPT model, ready to create amazing stories and poetry.